Welcome students. In today's class, we will discuss relay interfacing with microcontroller 8051. Basically, what is relay? So relay is an isolating device. So what it isolates? So basically, it isolates high power circuits. It isolates high power circuit with low power circuit. What does this mean? This means, suppose if I want to drive a motor, an electric motor, okay, an electric motor runs on a voltage of, let's say, 230 volt AC, okay, and my circuit which controls the speed of this electric motor is a very small circuit which works on a DC voltage, let's say up to 5 to 10 volts. So if I want to isolate these two circuits, okay, then I will use a relay. So mostly in some cases optoisolators are used, but here we are going to discuss what exactly is a relay, and how it works. Okay, so basically relay is an isolating device and it isolates high power energy circuits with low power energy circuit. So how it looks like? Basically the structure is something like this. It is a small square box like this. You might have seen such a types of relays in various electronic circuits. So this is the some relays are big in size, some relays are small in size. They are having two terminals out here. Here we provide a supply, and this supply is usually a DC supply. Okay, and here there are three terminals. There is one middle terminal, and two extra terminals are here. This terminal is called as a common terminal. This terminal is a common terminal, and generally this terminal is referred as NC and this terminal is referred as NO. So NC stands for normally close. NC stands for normally close, and NO stands for normally open. So such connections, such contacts are there. Now let us look at the schematic of, or let us say the internals of this relay, how it looks internally. So internally it has one winding, a coil, and along with that there is one connection like this. So these contacts are connected. So this one is connected and this contact is open. So usually this contactor, this common contactor, switches when an energy is provided. That means when an DC supply is given to this coil gets magnetized, and when it gets magnetized, this common terminal gets switched from this terminal to this terminal. So usually initial state wherein this common terminal is connected to this bottom terminal is called as normally close contact, NC contact, and the terminal which is not initially connected is called as NO contact or normally open contact. So what will happen when we provide the energy to this coil? This common terminal will get switched from NC to NO, and thereby initially which was NC terminal, now it gets converted as NO, and the terminal which was initially NO now gets converted as NC. In this way, it connects the external circuit which is working on very high power uh, to the low voltage circuit. So this is the way how the relay operates, how the relay works. Now here in interfacing we are going to look at how these relays are interface uh, with microcontroller. Okay, so we all know that microcontroller works on 5-volt supply. So what we basically need is a port pin. So let us say this is my microcontroller 8051, and let's say to its any one of the pin, I choose P2.0. To this pin I will be going to connect a relay, but relays are not directly connected, they are connected using a transistors. Okay, transistors are used to drive the relays because relays requires large current to flow through the coil and it gets energized. So for that we use current booster transistors, and at the collector side we connect and relay terminal, and here we provide a supply, and these are the terminals that we initially observed. This is a NO, then this is a NC, this is a common terminal, and here I have, this is my NC. Okay, in this way I can connect or I can interface the microcontroller with the relay. Now here you observe in between these common and NO I can connect my DC motor. So let us say for example I want to interface a DC motor or a AC motor, whatever high power device I want to connect. Okay, so let's say this is a motor I want to interface. Okay, so what I will do usually, this particular terminal is provided with high power. Okay, so let's say here I am applying a AC supply. Okay, for example I am applying AC supply to this terminal which is 230 volt. Okay, now when this coil gets energized, this NC contact will connect to NO. So this NO terminal will get connected to common, which I want to connect to the motor. So here this point of the motor is connected to the common terminal, and this point is connected to the ground or neutral. In this case this point is a phase point and this point is a neutral point. So when coil is energized, initially there was no supply to this motor. Initially there was no supply to this motor. The ground point is connected here, neutral point and common point is connected here, which has no supply because this is a floating point. But once moment I apply the voltage, or when current starts flowing by making use of this transistor, when transistor is turned on, what will happen? The energy starts flowing through the coil and coil gets magnetized, which will shift this common terminal, or which will switch this common terminal from NC to NO. When this movement takes place, this contacts happens and now NO becomes NC, thereby this P terminal gets connected to this motor, and at that time this point is open, therefore NC becomes NO and NO becomes NC, and motor starts rotating. When motor gets supply, it starts rotating. In this way you observe that high energy circuit, this is my high power circuit. If you observe this side of the circuit, this side of the circuit is a high power circuit, or high energy circuit, whereas this side of the circuit is a low energy circuit or low power circuit. And this relay plays a very important role of isolating these high power energy and low power energy circuits. In this way, the relays are interfaced with microcontroller. Now in today's this particular session or in tutorial, what we can say, we are interfacing a relay with microcontroller, and we are making use of Proteus software. As I told you earlier in my previous videos also, I demonstrated few interfacing such as interfacings of LEDs and interfacings of LED patterns I have shown. So in same way I am going to make use of this Proteus software and this Keil software. In Keil software we are going to write a program. We are making use of this Keil for writing program, and I am writing this program in a C language. Okay, while this Proteus is used for simulation purpose. So I have designed this circuit in this Proteus software, and I have already written a program in this Keil. I will let you explain how this program works, how this interfacing works, and then I will show its simulation. So let us switch to the simulation first. So this is my Proteus interfacing. In this interfacing diagram, let me show you. Here I have connected a switch at port pin P1.0. I have connected a toggle switch. Okay, when I turn this switch on, that means when this toggle switch becomes 1, I want this transistor to get turned on. When it turns on, this is a DC supply I am applying to the coil of the relay. When this transistor is turned on, the coil is get energized because current starts flowing through the coil, and when once coil is energized, the relay gets switched. Now you observe this relay here. This is a common terminal. This is initially NC terminal, normally closed, and this is NO terminal, normally open. Now here you observe I have connected one end of the motor to this NO point, and the other end of the motor is connected to the supply as I shown in the previous diagram. Now when coil is get energized, this NC contact will get shifted to this point, and when this will happen, what will happen? See, this DC supply will get appeared at the one end, and the other end of the motor coil gets connected to the ground, and in this way the circuit gets completed and the motor starts or the bulb gets glow. Now here instead of motor I use a load as a bulb. In the example I shown motor, but here I have used a simple bulb. So let us go to the program which I have written in a Keil. So this is a simple schematic which I have drawn here in a Proteus software to understand how the microcontroller programs and interfacing works. So let us go to the Keil program. So here this is a project which I have already written. Let me explain this program step by step. So this is my project window. Here I have added this relay control.c file. So this is my header file, which is very essential because you all know that all libraries which are necessary for microcontroller are written in this rec51.h file. Then this sbit command, you know very well that I have interface relay to the port pin 2.0. You observe carefully here. This is P2.0. Let me zoom it once again so you can understand. This is P2.0. To this 2.0 pin I have connected the transistor, and through transistor I have connected a relay, and therefore I have connected this sbit P2.0 as a relay. And similarly I have connected a switch, toggle switch at P1.0 port pin. Okay, this is a delay function, delay subroutine I have defined here. This is a definition of the function which is very essential at the beginning of the program, and always keep this practice of defining functions at the beginning before main function. So this is my main function, void main, and this is while loop. I already explained you this while loop works continuously unless until condition is true. While one is an infinite loop, it runs infinite number of times. Okay, so inside this loop I have written one condition that when this switch is on, in means this is a switch, toggle switch, which I have connected to port pin 1.0. So when this switch is on, that means when in is equal to 1, then I want this relay to be equal to 1, and when relay is 1, then what will happen? Automatically the coil gets energized and the NC contact will become NO, and for that situation I will be holding it for some time, that is delay equals to 20. If this condition is false, means if in is not equal to 1, then it will come to this else part, then relay will be off, and then it will keep in the off state as it is. Okay, so you compile this program, build it, you create a hex file. So this hex file I have already created. So see carefully here, I have created this hex file in my folder which I have already written. So now I will go to the simulation part. Let me reduce the zooming. Okay, now let me stop this simulation. I will download the file, go to this and get the updated file. This is a relay control.hex file, updated file. Click on open, this file gets open, click OK, and now run the simulation. Once you run this simulation, you will observe that this switch position is 0. Since this is 0, the transistor is in the off position. You observe this blue dot indicates there is a 0. This red indicates it is high, 1, logic 1. So 0 means it's a logic 0. So since logic 0 is given to the NPN transistor, this transistor is in the off state. Since this transistor is in the off state, relay doesn't get any supply because there is no path for current to flow through this relay coil, and therefore this relay is not energized. Moment I make this switch on, what will happen? This will make this P2.0 pin high. How we will understand that this pin is high? This blue dot will become red. When this is high, the base of the transistor is high, which makes this transistor on. Once this transistor is on, there is a path for current to flow through the coil completely, and the coil gets energized. Once the coil gets energized, this relay contact, which was initially at NC point, now shifts to NO. When this point shifts to NO, the motor will get ground point, and this point is already connected to the 12 volt DC supply, which I have connected to the one end of the coil. Okay, and therefore this lamp will get energized. So in this way the schematic has been done. So let us see the operation. So initially this switch is off. Now let me make it on. The moment I turn it on, you observe this 2.0 has become 1, that is red. Moment it becomes 1, the transistor gets on. As I stated, as transistor gets on, the supply gets connected to the coil. The coil gets energized, and the contact which was initially NC now switched to the NO. And you observe this NO point is now connected to the ground, which is one end of this lamp, and you observe this lamp gets glow. You observe carefully. This is the lamp. Initially it was off, now it is on. It is on. You can clearly visualize this. Okay. So in this way, I can turn my lamp or any application on or off. Let me show you once again. Run it once again. Okay, so initially it is on. Now I will make it off. Again run it on. Again make it off. Okay. Observe clearly when I make this switch 1, this relay contact will switch and the lamp will glow. So in this way, the relays and high power circuits are interfaced with the microcontroller. So keep watching. In the next video I will demonstrate few more interesting interfacings. So keep watching my videos. Thank you.